Assalamualaikum warahmatullahi wabarakatuh. My name is Najiha binti Abdul Rahman. Today I will present our part 2. In part 2, we need to answer 6 questions. First question is mechanical system. We need to find a mechanical system at least at 2 degree of freedom. And last, we need to explain system control in closed loop. For the first question, we choose bench drill. This type of machine drill is used for drilling lightweight pieces of material. For question number 2, this is our block diagram. Input is a power supply, output drilling, subsystem is driving motor, pulley and spindle, and signal is electric signal. For question number 3, this is our chosen question. We transfer that function using FPD and Laplace transform, and the diagram in black is our transfer function. For question number 4, after we get our transfer function, we transfer it into block diagram in Simulink. So this is our time response that I explained just now. For question number 6, how can the system can be controlled in closed loop? For system can be controlled in a closed loop with a controller. As for the system, the speed of rotation of the motor will depend upon the voltage supplied to the amplifier by the potentiometer. The value of the input voltage could be proportional to the position of the potentiometer. Apart from that, a gearing mechanism can also be used to control the torque of the drilling rotation. Therefore, in this case, a gear selector can be referred as a controller. That's all from me. Thank you, Doctor, for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Muhammad Azri, and my method ID is MA18176. So I want to present about the part 3, which is evaluation of time response and performance of the system. So for the question 1, we need to draw the block diagram from the part 2. So this is the block diagram. So after that, we need to write an M script file, such as in figure 3 in example, to run our Simulink model. So this is our M script. So after we do the M script, we need to use a step function with an amplitude of 1 to run the model to the M script. So we get the elapsed time is 2.615612 seconds. So in the time response graph, the elapsed time is 2.615612 seconds, which is it give a good result based on our equation parameter for the system. So after that, we need to identify the effect of variation of each parameter for our system to the time response. So we go to the question 2. So in the question 2, we need to do a new M file script and name it as task part 3. So this is our new M script. A new M script was created to it with the parameter which is f equal to 50, m equal to 100, k equal to 2552 under the parameter system. This parameter will be added into the workspace, so variable can be verified into the Simulink. So we need to define the transfer function is used to generate a transfer function. So the numerator while the denominator will have mbk, thus M script is ready to run. So this is our transfer function. So when the M script is ready to run, the transfer function that can show 2 degree of freedom will prompt out in the command window. So this is our time response analysis. This command will open the LTI viewer window. LTI viewer is a time response analysis tool. So this is our step response graph. And after that, we need to identify all the performing characteristics of our system by finding the settling time, rise time, steady state value, and the peak response. So this is our, so lastly is for the steady state value and the peak response graph. This steady state value is at 1.92 and the peak response is at 450 seconds. So after that, we need to identify the effect of variation of each parameter of our system to the time response. So we must create the new M script with the variation of the parameter. A new M script was changed to add with the parameters, which is f equal to 30, m equal to 50, k equal to 2400 under the parameter system. So after that, we get the results uh, in the step response graph. So our settling time is set to be at 255 seconds, and the rise time was allocated at 144 seconds. So we can conclude that after a variation of parameter being made, the result in the time response will be changed too. To have a better performance, we must improve the system with a suitable value of parameter, because it will become an important factor to achieve a good system and give a good result. So that's all for me. Thank you.
Okay, hi, my name is Muhammad Shamahika. I will present about the stability analysis was a RH method for Posigomet that I put the parameter into the coding or script that that I used to get the time response. So this is indicate for zero and this indicate for poles. So as you can see, the post is on the left side. Is a zero. So the opposite that we get in the negative region. So the stability of the system is unstable because if the pole occur at the left half plane, so the system is said to be stable. Okay, for the RH criterion, I need to calculate our transfer function. So first we need to complete the table and we see there is have a sign chain. Okay, this is an advantage and inconvenience. Okay, for position, the advantage was one is easy to obtain the result for stability, less error occur. The stability of a linear system may be determined daily from its transfer function. So we just put.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Abu Bakar. My matric ID is MA18188. For project report automatic control, I will present part 6, root locus. Firstly, we need to use MATLAB to plot the root locus. This is the transfer function, and figure 6.1 is the script to plot the root locus. Next, we have figure 6.2, which is the command window, and based on the command window and the script, we will get the figure 6.3, which is the value of graph result and the graph of root locus. Based on the graph of root locus, the result has been shown. The frequency at k equal to 0 is 0.021 radian per second. The number of root locus branches is equal to the number of closed loop holes, which is 2. Around the real axis, the root locus is symmetrical. The next task is we need to do the calculation based on the transfer function. Then we calculate the poles, which is negative 0.02104 and negative 0.96918, and we calculate the zeros. Then we make a table of s square, s power of 1 and s power of 0. Then we can calculate the value of k, which is negative 50.54, and based on the value of k, we need to substitute it into equation s square, and we get the value of s is plus minus 1.4j. last but not least, we need to calculate the break-in point. And we get two value, which is negative 0.02055 and negative 0.96878. That's all from me. Thank you.
Okay, Assalamualaikum. My name is Nori Fausna binti Muhammad Mehrazuki, and my metric ID is A18152, and I will be presenting to you about part 7, which is PID controller. Okay, PID controller is also known as a three-term controller, which is a control loop feedback mechanism. So about 90% of all control loops are closed with some form of PID controller. It is widely used in industrial control system and a variety of other applications requiring continuously modulated control. So PID controller also continuously calculated an error value as the difference between a desired set point and a measured process variable and applies a corrective based on proportional, integral, and derivative terms. So at the right of the slide is the structure of the control system, and from there we can see the PID control system. Okay, this is the derivation of equation 1 and equation 2, and then equation 3 and equation 4, and the function of the PID controller. Firstly, it is proportional, faster response time and overshoot, and then integral, it will eliminate steady state error, and then derivative, which is to reduce overshoot. So this is the advantages and disadvantages of PID controller. So the advantages is the process independent. It also leads to a reasonable solution when tuned for the most situation. It's also inexpensive because most of the modern controllers are PID. It also can be tuned without a great amount of experience required. So the disadvantages is first, it's not optimal. It can be unstable unless tuned properly. It's also not dependent on the process, and then it will cause hunting, which is oscillation about the operating point, and then the derivative noise amplification. Okay, this is the result. Firstly, this is the coding for the PID controller, and then from the plot, we see the both of the steady state error and overshoot are too large. Increasing proportional gain (Kp) will reduce steady state error. However, it can cause increase in overshoot. So the PID control, by adding an integral term, will eliminate steady state error to a step reference, and a derivative term will often reduce the overshoot. A small Ki and Kd is used. Okay, here this will indicate that the steady state error does indeed go to the zero for a step input, but takes time to reach its steady state, which is far larger than 3.5 seconds. Okay, then long term on step response graph is due to the fact that the Ki is small, thus the long time to build up will eliminate steady state error. So this process can be sped up by increasing the value of Ki. As expected, the steady state error is now eliminated much more quickly than before. So however, large Ki has not been in overshoot, so in attempt to reduce the overshoot, Kd is increased. Okay, this is the coding of PID control with a large Ki and large Kd. Okay, as you can see, the increase in Kd reduces the resulting overshoot. By using PID controller with shown values, all of our design requirement will be satisfied. So, as for the conclusion, using PID controller is certain to make the system meet all the design requirements. So, by using only Kp, cause the overshoot and steady state error to be so large. So, by adding Ki will eliminate steady state error, and Kd will be reducing the overshoot. So, after altering value of Ki and Kd, we finally achieve the design requirement. That's all from me. Thank you. I will pass to next presenter.